Alright, so we're going to talk about radical equations and solving these equations. So your goal is to isolate the radical. Okay, so sometimes the radical is going to be isolated already and other times it won't. So let's go ahead and solve. So as you notice here, the radical is isolated on one side of the equation by itself. So now that you do that, you're going to go ahead and square both sides. That's how you get rid of the radical. So the radical and the square cancel each other out, and all you have left is 2x minus 3 equals 81. Then you'll go ahead and add 3 to the other side. You get 2x equals 84. Divide by 2, x equals 42. And the other thing you want to do is you want to make sure to check your answers. Now, not all solutions are going to work, and that's why you really need to check all your answers. Okay, so this is going to give you 2 times 42 minus 3 equals 9. Okay, and then you're going to get 84 minus 3 equals 9. 81 equals 9. 9 equals 9. So that one works and it is a solution. And then I just like to circle it afterwards. Alright, so this next one, remember your goal is to isolate the radical. So in this case, it's not by itself on one side of the equation. So I'm going to go ahead and subtract 3x to the other side. And then you're going to get radical minus 10x minus 1 equals negative 3x. Okay, then what you're going to do is you're going to go ahead and square both sides. And whenever I'm squaring something, I want to put parentheses around it. So the radical and the square will cancel out, and you're just left with negative 10x minus 1 equals, this is negative 3x times a negative 3x. So that means negative 3 times a negative 3, that's 9, and then x times x, that's x squared. Okay, so now you're left with a quadratic. So you're going to go ahead and do plus 10x plus 1 plus 10x plus 1. So you're left with 0 equals 9x squared plus 10x plus 1. Okay, so what we want to do now is whenever you see a quadratic, you're going to try to factor it. You could also use quadratic equation if you remember that from Algebra 1, but most of these are going to be factorable. So let's go ahead and do our little parentheses here from last section. And then I'm going to try 3x and 3x, and then maybe plus 1, and then remember we're just going to see if this works. So 3x, so if I add those I get 6x, which is not that middle term, so I have to try again. And I can't, there's no other things that multiply out to 1 and 1, so I have to try another way to multiply 9. So I could do 9x and x, And then I think that's going to work. 9x, 1x, add those together, I get 10x. Okay, so that works. So you could rewrite this to say 0 equals 9x plus 1, x plus 1. And so this is the new step. I'm going to go ahead and do this in a different color just so you guys could see. So this is a little bit of 5.8 that we kind of skipped over, but we're going to go ahead and cover that now. So what you want to do is you want to set both of these parentheses equal to 0 and then solve for x. So now I'm going to subtract 1 and then divide by 9, and I get x equals 1 over 9, and then subtract 1, x equals -1. Okay, so next we're going to plug these into the original equation to see if they work. So we have x equals -1 and x equals -1 over 9. Okay, so let's plug in -1. So -10 times -1 minus 1 equals -3x times 1 for the x. Okay, so this gives you -1 times -10 is 10 minus 1 equals 3, square root of 9 equals 3, and then that should be 3 equals 3. So that one worked. Okay, next we're going to go ahead and try plugging in the 1/9. Alright, and over here we're going to get 10 over 9 minus 1 equals, and then this would give us 1/3. Okay, so I'm going to go ahead and get common denominators here. So multiply 9 over 9, and then this is 10 minus 9. So I'm going to rewrite that. And so you get 1 over 9, and that's still in the square root. And so that's going to be equal to 1/3. Okay, so then they both work. Alright, so let's go ahead and try this last one here, which is solve the square root of 4 minus x equals x minus 2. So again, you already have your radical isolated on one side of the equation, so we're going to go ahead and square both sides. Okay, square both sides. And then remember, I like to put parentheses around this. So the square root and the square will cancel each other out, and you get 4 minus x equals x minus 2 squared. Okay, then I'm going to try to simplify that right side. I'm going to use a box. I'm going to just do some side work. And x minus 2, x minus 2. So this is x squared, -2x, -2x, and positive 4. So you could combine these ones. So you're going to get x squared minus 4x plus 4. Okay, so that's the right side. Next thing you're going to do is, whenever you see a quadratic, you should always try to move everything over to one side. So I'm going to go ahead and subtract 4, add x, and then what you should get left on one side is 0. Okay, and then those cancel out too. So here we could do factoring, and so we're actually going to factor out an x. That's what they have in common. And there it's factoring. So again, this is that 5.8 is whenever you have a 0 equals and then two things that are being multiplied, you set both of them equal to 0. So x equals 0, x minus 3 equals 0, and that's called the zero product property. Okay, so then you just have to isolate the x. So this one's already isolated, so just add 3 over to the other side. X equals 3. And then don't forget, we still need to check our answers into the original equation. Okay, so I'm going to go ahead and scoot this up. And then I'm going to go ahead and write down the original equation. Okay, and then we're going to plug in x equals 0 and then x equals 3. Okay, so let's plug in 0. 4 minus 0 equals 0 minus 2. The square root of 4 equals negative 2. 2 equals negative 2. This is false. So x equals 0 is an extraneous solution. So a solution that didn't work, we call that an extraneous solution. Okay, so now let's try 3. So 4 minus 3 equals 3 minus 2. So that gives you square root of 1 equals 1. 1 equals 1. So this one did work, right? So then what I'd like to do is just cross that out and box that. And again, somewhere in your answer, you have to say which one is extraneous, if there are any. So I went ahead and said, so x equals 0 is an extraneous solution.